today, but let's rehash what we talked about yesterday, just as a quick review. First, we said, okay, if I have a triangle, it has 3 sides. It's got a sum of 180 degrees if I add up all the interiors. Then we talked about a quadrilateral having 4, and we said it's 360. Then we said you could keep adding 180. But the most important thing is quadrilateral, because this whole chapter, up until spring break, we're talking about quadrilaterals that have parallel lines. If you have a quadrilateral, if I say you have a quadrilateral where opposite sides are parallel, you have a parallelogram. That's the one rule you need to have a parallelogram, that opposite sides are parallel. As soon as I tell you opposite sides are parallel, you then know these 4 rules. That opposite sides are the same, opposite angles are the same. We have consecutive angles are supplementary. That means they add up to 180. And then I said diagonals bisect each other, so we have kind of those midpoints of both of those particular diagonals. Now, I also said you might want to write this on that yellow sheet. That yellow sheet will be your review sheet, so you don't have to go back to all these chapters every single time, because we're going to keep adding to it. So look at all those shapes on that yellow sheet. We need to be able to do all of those. All right, I know some of us already did this. We're going to kind of bounce around these problems. We're going to go through it, and then your group is going to be responsible for all the ones that I missed. Did you have a question? Oh, no. Okay. So if you did it, awesome. But otherwise, we're going to bounce. Yeah?
Are we allowed to ask questions about the homework?
Let's hold on till after the lesson, because not everyone did it, but then we can talk about it. All right, so number one, you should have realized that as soon as one of the sides gives you a length. So I look at this side has 15. What does A being 15 help me find, or what missing side can I find because of that? Yeah. DC. I could find DC because we know that these two things are congruent to each other. So we can go, oh, DC should be 15. How do I find AD? Yeah. It's opposite of 8. So realistically, if I have a missing side, I just first look to see if the other side has that number on it. So AD would be 8. Then it says find measure of angle A. How do I find measure of angle A if D is 68?
That means that angle D is 68, and then you add those two together, and then subtract that from your 60.
Ooh, there's an easier way. I agree with that. So Griffin said, oh, go across here. Do my angle B equals 68 degrees. And then you said, okay, subtract that from 360, divide by 2, and you have those other 2 angles. Can someone tell me another way I could find angle A knowing that D is 68? Key.
You can subtract 68 from 180.
I could just do 68 from 180 rather than having to add them all up, because these have to sum to 180. These 2 angles add to 180. So we could just do 180 minus 68 would give me 112 degrees. Now, Griffin, would you come up with 112? Yeah, it works. It's just something that's easier with smaller number because then you don't have to do your calculator. But if you understand that it's 3, that's why I brought up the fact that it equals 360. It's always nice to have multiple different ways to get to a value. Always a good idea to have multiple different ways to get to a value. So that means A is 112, and it also means C is 112 because they're opposite each other. All right, I'm going to skip 2. I'm going to skip, let's talk about 3. Let's talk about 3. All right, how do I know UT? Yeah.
It's 27 because R and S.
Yeah, because R and S is opposite UT, so we'd go, okay, that's 27. How do I get ST? Someone new. Everett. The other side's 18, so we go, okay, these 2 things are 18. All right, now follow me for this question. Why is RT equaling 30 going to help me find one of those missing sides? How is RT being 30 help me in this particular problem? Yeah, Will.
You can split up like RV and VT. You can split up 30.
So we can split those up from 30 and say that they're both 15, right? And since UV is 7, VS is also 7, so we have all of these numbers here. Yeah, Flynn.
Wait, so why is the VT, why is it 15?
Why is 15? Because R to T is 30.
Oh, it says that there?
Yeah, it says it right here. So RT is 30. So that means we can split in half because we know they're both equal. Yeah, That's why I'm putting in the homework, because this is the easy way to say RT, because it's hard to say that RT is 30 without putting some note to you, so you don't have to do this other
So what would we have
thing
to do
here.
if we didn't have that defined?
You'd have to have something else.
Okay.
Yeah.
I understand like the process, but how do you know that they're going to be equal?
Because of our rule that diagonals bisect each other. So if it's a parallelogram, we automatically know. Now, we don't know all 4 of them are equal to each other, right? They're not all 15, but I know if RV is 15, VT has to be 15. So, like I said, we should probably take some time on our drawings to actually let us know that once it's a parallelogram, that this is true, that this is equal to this, and this is equal to that. In other words, think of this middle one as being the ultimate midpoint for your parallelogram. This point right here is the ultimate midpoint for your parallelogram. All right, I want to talk about number 4, because number 4 leads to a common mistake that people make. Do you see this 21 degrees right here? So I have C, F, G. Remember, when you're naming an angle, you pick 3 letters, and the middle one has to be a vertex. So if I say C, F, G, there's only one angle you can look at. It's 21. Let's talk about the most missed thing I see. People will look at this and go, oh, this must be 21 degrees as well. Did I ever say the diagonals are angle bisectors? Look at your 4 rules. Does any of them say there's an angle bisector? No. That's actually a specific shape. When we get to a rhombus, there'll be bisectors. But it's a regular parallelogram. A regular parallelogram will not have both of these equal. However, if CFG equals 21 degrees, does anyone see another angle that would also be 21 degrees? Yeah. EDG. And why would those 2, what kind of angles are this one and this one? What's the specific name I could use for those? Yeah, Mason.
Isn't it alternate interior?
Those are alternate interior angles. So these 2 are congruent. And I'm also looking at that 71 degrees. And I'm saying, you know what? That must be equal to DCG should also be 71 degrees. Because once again, these are alternate interior angles. Now, that is not a rule that we need to write for parallelograms. That's just a rule for being parallel lines. That alternate interior angles are congruent. So although it's not a rule that we have up there, you have to know this rule. In parallelograms, which means it works for every shape that's going to fall under our parallelogram umbrella, that these are alternate interior angles. All right, then we have to look down here, because we're going to start realizing there's important information, like on problem 3 was RT equals 30. This one says FED equals 134. So I'm just going to take a little angle and say, okay, this big angle is 134 degrees. So angle FED is 134. If this is 134, now pay attention to my question, what would CDE equal? So I'm looking at this big angle right here. What would that equal? Because that's a good one to go to first. Griffin. 63? I don't think it's 63.
I have 6.
I think
I have 46.
how did you do it though? Can you walk me through?
I accidentally subtracted 134 from 71.
What should you do?
Should it be 180?
It should be 180 minus that 134. Yeah. That's how I knew it when it ended in a 3, I'm like, that's not going to work. So we should have 46 degrees. So I take these big angles first, and then I can go down to the smaller angles and go, oh, well, I need to have 71 plus some angle equals 134. What is that angle? 71 plus what would give me 134? Mason? 63. I think that's where the 63 came from. And then I need basically EDG plus GDC to equal that 46. And if I'm subtracting 21 from it, I should be left with 25 degrees. Do you notice how I did all this without really looking at what I needed to find? I think sometimes that makes it easier just look at the information's given to you and look at the stuff that you can find on there, because usually I'm going to ask you for all that information. Now I have everything I need to label these, so now let's just look through it. So it says DEC. DEC would be that 63 degrees right here. Remember, DEC, read it in order, so that would be 63 degrees. CDE, start at C. DE is that big angle we already found at 46 degrees. ECD, ECD, oh, I already labeled that as 71 degrees. And DFE, DFE, we don't have it labeled, but we know it's alternate interior angle to the 25. So that should be 25. Do we all see where I got the 25 from? Alternate interior angle. So I took the time just to label all the stuff that's important, because sometimes if I start getting in the clouds where I'm like, oh, I need to find this angle, I have no idea how to do this. Well, how about you just start at the ones that are labeled? Always start at the one that are labeled and see where you can go from there. Make it a puzzle for, if I tell you this is 71, how far can I go with that? I can go alternate interior angles. I can go, they gave me this big one, that gives me 63. It also gives me this. So see how far you can go with the numbers that are given. Don't just go, I don't know how to find this angle. I'm going to tell you, start from the beginning. Look at what information is given to you. All right, let us go through this one. I got two more I want to go through for sure. All right, so this one, probably a good idea not to just do everything in your head. So what I mean by that is, how about we take these numbers and actually put them on our drawing? So I can see that we have xy equals 15. So I need to find my xy and put that down as 15. Now, I might stop there. Xy being 15, what should I immediately think? When I say xy equals 15, I should already have a next step in mind. If I say xy is 15, what should our next step be? Can we not rush ahead? I just want us all thinking like this. Everett? Probably wz equals 15. So as soon as I get one information, I'll probably just see what else we can do with it. So just like if I say wx is 22, your first thought should be zy equals 22. It could also be that we look over here and see if we can fill in that information. It does ask for zy, so we'll go zy is 22. Does it ask for wz? It does right there is 15. All right, already got two done. All right, then it says zx. Zx is 32. Can we all look at zx equaling 32? I am not going to put 32 on my drawing. What am I going to put instead of 32 on my drawing? Flynn?
16.
16. I'm going to put two 16s. So notice how hard it'd be to label this as 32, because 32 kind of looks like this, and you're like, what did I label as 32? So instead of 32, I'm going to go, okay, z to x is 32, so I'm going to list this as 16, and I'll list this one as 16 as well. Do we need to do zt or t? Oh, we need tx, so I already have that done. Let's cross out that. Wt equals 10. If Wt equals 10, what else do I know? Ian? I know Ty is also 10, because both of those have to be equal. Do they ask for Ty? They do not, but they ask for Wy. 10 plus 10 is going to be 20. All right, so like I said, as soon as you put down a number, see how that impacts the rest of the drawing. So now we go, okay, I'm done with all the lengths here. Now we have WZY. WZY. That's the big angle right here. WZY is 62 degrees, which means this WXY will also be 62 degrees. What other angle do I know? So I have WZY is 62, so the one across from it is 62. What does that 62 also give me? What does that 62 also give me? Michael?
How much, like if you subtract from 180, subtract
Perfect.
So you can get the measurements of ZYX and ZWX.
Yeah, so we're going to come up with 118, right? So we'll have both of these are 118. Let's see if that answers any of our questions over here. So we're supposed to find T. Oh, man, I covered up all my letters. TZY, not going to help there. XYZ. XYZ. So that's going to help us there, right? We're going to have that 118. XWT. XWT, not going to help us there. XYT.
Wait, wouldn't XYT be 118?
Which one did I miss? XYT?
Yeah. Would that be 118?
It could be. I covered up my letters here.
It's the...
Okay, there it is. Yep. I just had my I shouldn't cover up my letters like that. Let me go back here. So XYZ is 118, and you're telling me which other one do you think I could fill in? XYT. Well, XYT will be this angle right here. I haven't put any information. It'd be this angle right there. XY. X.
Not 118.
XWT.
Yeah,
XWT would be this angle right here. It'd be one of the small ones. So we have to go further. So we do have the 62 is done. It does say WX equals 20, or WXT. So WXT is going to be 27 degrees. Let me put that in red. So that's 27 degrees. And it also says ZWT is 77. So ZWT, which is that angle right there, is going to be my 77 degrees. All right, let's see what we need to find. We need to find TZY. TZY is this angle right here. What would that measure be? Yeah, Michael. It'd be 27 because they'd be alternate interior angles. What I'm looking at is this would be congruent to this. So we go 27 degrees. All right, XWT. XWT would be this little angle right here. That's one I think you were talking about in the beginning, right? So this little angle right there. Well, this is 118, right, total? So we subtract 77 from that. 41. That'll be 41 degrees.
Wait, so why would you subtract 77 from that? Yeah, why do you...
So we know that this is 77 degrees. We know that the big angle is 118.
Okay.
Angle addition postulate says angle plus angle equals big angle. If I know this entire big angle is 118 and part of it's 77 and the other part must be 41, so when you add them together they equal to 118.
So with the, what's it called, alternate interiors, does that still work, 118, or is it a big angle so you just...
Well, 118, this one's going to be 118 because it's the big angle. Alternate interior angles would work, so see how this one's 41?
Yeah.
That means this one would be 41 here. If this is 77, then X, Y, W would be 70. So you only use alternate interior angles for the smaller ones, the ones cut by the diagonal. All right, I'm already lost. Did I say there's 41 degrees for the next one? All right, cool. And then we have one more, X, Y, T. X, can we stop that? X, Y, T. Flynn, this is when we use our alternate interior angles. Because I'm going to go, okay, X, Y, T. Oh, that matches up with the 77 because those would be our alternate interior angles, which means this one would be 41. We can actually get all of our angles from there. So we're going to go with the 77 degrees. Any questions on how I did any of those? So what's the biggest challenge you think in this? I think one of the biggest challenges is to know your rules. The second biggest challenge is staying organized. Because as soon as you're not writing numbers down or keeping track of stuff, you lose your safety net of getting stuff wrong. So if you just don't write any numbers on here and you mess up one of these angles and all your angles are wrong and I don't see work over here, we lose all of our points from, and there's no way to get them back because you're doing everything in your head. However, if you're marking stuff up like alternate interior angles, you're showing me where things are equal to each other, then I can look back at your drawing and figure out what you mislabeled. And hopefully that can save you from that. Okay? So this had a lot going on, a lot of points there, but most of it was just moving numbers from one side to the other, alternate interior angles, and knowing that a big angle is made up of two smaller angles. All right, I'm going to push on, and let's pick one of these, 7, 8, 9, or 10. Which one do you not want to do on your own? 10? All right, we won't do 10 on our own. That's a really good one to actually do because they give us a bunch of information. They first tell us ABC equals 115 degrees. So they say this big angle here equals 115 degrees. So I'm looking at this big angle right here. I'll even highlight it extra more, that is 115 degrees. Why'd they give us that? Can I just put 6x minus 11 equals 4x plus 6? Can I just say those two things are equal to each other? Nick, you're saying no. Why not? Because they're not alternate interior angles. To be alternate interior angles, it would be this angle is congruent to that angle. So what we could do is we could take this and push this angle up here. In other words, what I'm picturing is, well, let's say that this angle here, maybe I'll just do this. I'll put it out here. That angle is also 6x minus 11. You don't have to know a value to say it must be equal to that. So if I tell you this is 6x minus 11, you're like, that is also 6x minus 11. What equation can I now write? Yeah.
4x plus 6 plus 6x minus 11 equals 115.
115. That is your goal. And these problems, either they're equal to each other or they sum to something. Now, Nick said they're not equal to each other because they're not alternate interior angles, so that means I need to come up with something where they sum together. So just like you said, angle plus angle equals big angle, so that means 4x plus 6 plus 6x minus 11 has to equal that 115 degrees. Now we just solve for x. So 4x plus 6x equals 10x. 6 minus 11, that's going to give me a negative 5 equals 115. We will now add 5 to both sides. We're going to have 10x equals 120. Divide both sides by 10 so that the 10s cancel out. And I'm going to have x equals 12. Now, what did it say? Does it say solve for x? No, it says that we have to find angle ADB. I need to find angle ADB. So let's figure out what ADB is. So ADB, bless you, is that 6x minus 11, right? So our angle, measure of angle, was it ADB? Is going to equal 6 times whatever my x is. In this case, it's 12. Minus 11, that would be what, 72 minus 11? 72 minus 11 is going to be 61 degrees. Did I do that correct?
Yes. Yep.
So I have 61 degrees. What was that?
Is that minus 1 or is that?
Minus 11. Oh, it should be minus 12, shouldn't it? No, we're good. It's minus 11. I'm sorry. Because it's 6x minus 11. 6 times 12 minus 11. All right, questions on any of those problems? All right, it is your job with your group to finish the ones we skipped. All of them. And if you're done, awesome. That means you need to help out your group because I need your group to get these checked off. So that's number 2. Number 2 should go quick. We went through all these, so we need to do number 2. We need to do number 6, 7, 8, and 9.